At the early stages of creating our AI agent, we had created a prototype which was a great proof of concept. But at the time, we didn't know it had a fatal flaw that would completely doom the process. So let's talk about it. Hi, I'm Will, and my co-founder and I have created Charlie, an AI agent that is able to take a price quote creation process that normally takes at least 3+ hours down to 15 minutes, always allowing and providing the complete control to the expert doing it. Today, I want to talk about the early stages of when we were building Charlie and when we were just extracting the knowledge that my co-founder has about creating price quotes. My co-founder had been creating price quotes for 7 years in the trade show industry. And so we were basically building the whole instructions that would go inside of Charlie. The process was pretty simple, and at the time we wanted to make sure that the input of the process would be the same as what an actual user or expert would be doing without AI. And so that usually starts with a proposal. The proposal is what is sent to the customer, to their customer. So it's kind of like, hey, here's a concept. What do you think? It includes 3D views, floor plans, elevation plans, essentially everything that you need to know to create a price quote. Someone who's experienced in that can actually create a price quote from this. It does take some time. You have to look at the 3D views. You have to actually analyze what is in there, but you do get to the point. And so it's always in 2 steps. You look at the proposal, you create the line items for all of the categories: electrical, floors, walls, ceiling, all those things. You have to write really detailed with the dimensions and stuff like this, like for example, 50 meters squared of that kind of floor, to be able to then get to the second step, which is the pricing. And so that is probably the identification and the writing of those line items, the process that is the most difficult because it takes the most experience. And so that proof of concept was to say, hey, can we actually get to a point where we can write the instructions, provide the proposal, and then we get out the line items? And it worked. After a few months of working on it, my co-founder was able to pull out this Claude instructions, and we had a pretty good output in terms of having from the proposal the whole line items being described here, which was first of all a great news because that proof of concept was actually, it confirmed that it was working. But it had a fatal flaw, and we saw it because we ran it again and again with the same project to see kind of the consistency, and we saw that it had some issues with the precision. And so we weren't sure at the time if it was prompting or not, but I had a hunch that it was more its capacity to actually view things on a plan. So typically the kind of things, for example, that where you have like numbers or linear meters or meters squared, so kind of exact dimensions, that wasn't cutting it. The precision was not good, and it kind of defeated the whole purpose of having an agent, because that would mean that we would say, hey, to the user, please double check always the precision of those things. And so that wasn't going to be the right approach. So we were kind of like back at square one of like, okay, well, we have something that is relevant in terms of what the line items are created. We can see that it views stuff, but it's just not precise enough. And reliability for agent like this needs to be, top. It can never be 100%, just like for if actual humans were doing the process. But you have to get to a point where people can feel reliably that, yes, it's not just nearsighted. Like, I'm not asking someone who has really bad vision to drive. I can actually trust the process here. So we thought, fair enough, let's ask a confidence score. Maybe we can actually identify what measurements the AI is not good at figuring out. So we asked it like, hey, if you see a measurement that you're not sure about, you provide a confidence score. Say like, hey, for this one, I'm not really sure. We tested this, and the results were not good. Sometimes it would give us false positive, false negatives. That means that sometimes the measurement that it found was correct, but the confidence score was low. Sometimes the measurement was wrong, and the confidence score was high. So this meant we couldn't trust it. And to understand why that is, essentially vision tools, the vision capacity of those models is kind of defined at birth. It's not really at birth, but at the end of their training. And different models will have different capacity at viewing things. Like, they're not made equal there. Some companies, as they're building those models, focus on different things. And that would be a topic for another day. But this was the case where Claude had a specific vision capacity defined at the end of its training. And so asking it to provide a confidence score is always based on a relative kind of, what would be the actual truth based on, okay, well, I'm not really confident based on the truth. But the things that Claude didn't know, or we don't even know, like the capacity of Claude to actually view things in detail. So it's not even able to actually provide us with a confidence score reliably. It would be similarly to how asking dogs, this is an illustration apparently of what dogs see on the right. It would be asking a dog how confident it is that the toy here is green. First of all, if the dog answers, then that's incredible. But if it was saying like, yes, I'm really confident that the toy is green. Sure, we don't know exactly because we know that the toy is not green, but the dog doesn't know. So it's pretty confident that the toy is green in that case. So we realized that we couldn't really ask the model a confidence score. And so we couldn't be like, hey, just figure out the things that are not reliable and ask the user to confirm. So we were back at square one. Back then we had kind of put aside Gemini, the Google models, because we thought, we didn't feel right with the vibe. It was, I think, Gemini 2.0 Pro at the time that was out, and the quality of the discussion and the user experience wasn't great. So we thought, okay, we'll just put it aside. But then after trying to figure out, well, how could we improve the vision, came across the vision leaderboard in the LM Arena, which is just this leaderboard that defines which model is best at. There's text, web development, and this one was for vision. And Gemini models were always really good. The reason for this is going to be a whole nother can of worms, and that would be in another video of why models are better than others. But we thought, okay, well, let's try again to use Gemini 2.0 Pro or 2.5 Pro, which was just releasing at the time, and see what is the experience there. So we thought maybe let's try to actually provide and do the whole process of using Gemini 2.5 Pro. But it was still not cutting it. The conversation was not great. So again, we're back at square one. It was like, okay, do we either choose to have the precision of a Gemini model, which was really good. We had tried to provide, the same floor plan and asked it again and again, or different floor plans. And in our test, we saw that the precision and the capacity of looking at things and understanding things visually was way better than Claude. So we were at the stage where we thought maybe the only choice that we have is either a bad conversation experience, but a good precision visually, or a good conversation, but a bad precision visually. And I guess that was the choice that we had. Or did we? After spending a bit of time thinking about this, I thought, let's try to have the best of both worlds. And we just want to have the vision capacity of Gemini. So let's just allow Claude, in that case that will become Charlie, our orchestrator model, to ask a question to Gemini, basically providing a way with a tool. So tools will be another topic for another video, to Charlie to be like, hey, look at those files. Can you let me know what you see? And so this is how we got to create the vision tool, allowing Charlie to ask a question to Gemini. So let me show you what it looks like. So when you start a conversation with Charlie, it's going to, first of all, look at the document. And so we can see that the vision tool here has just triggered. And in a few seconds, there we go, we're going to have this vision analysis panel. And so this is basically Charlie asking the question to the vision tool. And behind this is Gemini 2.5 Pro. So this will take a few seconds because the PDF is pretty big, about 40 seconds in general, but then you're going to have actually the output. So let's wait for it. And so now, after a minute of waiting, and it's kind of normal, it takes a bit of time, we have all those different descriptions of the plan of the document. And so that was the proof of concept that this worked. And we tried it, and it was the best in terms of the quality of the vision and the precision of those conversations. So that was pretty incredible in terms of proof of concept, because we were able to see, okay, well, we have Charlie and it's able to actually get the information from the vision tool. It was the best that we had at the time, but it wasn't still incredible. We had some issues with reliability. Sometimes we saw that even though Gemini had provided the right measurements, Charlie, in the way that it was creating the line items, was not correct. It was not the right measurements. So we thought seems to be some confusion between Charlie looking at its own PDF, its own documents that we passed it, and also the answer from Gemini. We tried a bunch of prompting as well, but that wasn't cutting it. Like all of the prompting you could do was not cutting the precision problem, even though like we had to say like, do not look at the PDF you were provided, just look at Gemini's response. So that wasn't enough. So we thought there needs to be a more robust approach. And so we thought, okay, you don't want to not look at the PDF. That was to Charlie that we said this. We're going to make you not be able to view those PDF. And so we basically made Charlie blind. We didn't allow it to actually view any kind of PDF or images. We did tell it like, hey, by the way, the user provided this document, this PDF, this image, and its name is this, but you can't see it. You can't view the tokens. That actually made the whole difference, because then the only way that it was possible to look at something, to look at a document, it was to pass it to Gemini. And there it was. The precision, because only the Gemini answers was taken to actually view the measurements, only the answer from the vision tool, plus also the capacity for the user to actually verify what Gemini was saying, so actually viewing the outputs. And this had a bunch of other benefits. First of all, the context pollution. So that means that even though we had, we wanted to make sure that Charlie was not looking at the PDF tokens and data, it was still always loaded up. So every time there was a new message, by providing this PDF and those documents, it was still taking a lot of context. And sometimes the instructions or the discussion was kind of lost. For context, a simple 35-page PDF is 60,000 tokens. The instructions for Charlie at the time was 50,000 tokens. So it was taking more space and more token than this specific, the actual instructions. The other benefit was just the cost, right? You didn't have to provide at every message the tokens for this PDF, which made it actually had us cut the cost of the document processing by 46 times, which is an incredible cost cutting in this case. And also the speed. The less tokens that you have, the faster it is to actually get the answer. And so we had a better user experience in that case, because the first message was not as long, because Charlie was able to say like, hey, I don't need to actually look at the tokens. I don't need to tokenize and break up all this documents so that I can understand it. I don't even have it, so I don't mind. Lastly, one of the advantages was also to decrease the risk of going over the context window. At the time, the context window of Claude was 200,000 tokens. And so when you're starting off with 50,000 tokens plus 60,000 tokens, so 50,000 is for the instructions, 60,000 is for the PDF, and this is just for like the 35-page PDF. Sometimes those proposals are even bigger. So it was a risk that if a user was providing a proposal of a much bigger booth with a lot more 3D views, a lot more pages, there was a risk of either going at the very beginning over this 200,000 token window or get close to it at some point. And so that wasn't acceptable in that case. And so that solution of making our agent blind was truly the right solution. And so I guess the end situation here was to have Claude be able to ask Gemini and be blindfolded in that case. To ask Gemini what is inside of those documents and files. So if you want more implementation details on how we're building Charlie and try to make it more reliable and as effective as possible, feel free to subscribe. I'll post more stories like this. Thanks for watching. I'll see you in the next one.